Welcome back to another episode of Sm.I.E videos. This is Nate, and today I want to jump into a continuation of the short series that I started on troubleshooting by looking at another troubleshooting exercise. So if you're ready, let's go. Alright, so if you're following from the last video, then you remember we spoke about what troubleshooting is, and we gave some tips on the more popular methods of troubleshooting and which one might be the better method to use. If you missed that video, don't worry, I'll leave a link in the description so you can check it out. Once you're done, then you can come back here and we'll continue. Go ahead, I'll wait. Otherwise, let's jump into the next exercise. Alright, so just a point I wanted to emphasize from the last video. Well, a point about troubleshooting overall. A lot of times when you encounter an error, the system will give you an error message. Depending on the type of system and the particular error, you might even get error codes. It's very important that you read these messages carefully. Let me say that again. It is very important that you read these messages carefully. Why? Because oftentimes they are going to be the key to your salvation. Like what we saw in the last video, where the error message actually referenced the DNS as being a possible source of the issue, and it eventually turned out to be the actual issue. Alright, so we're logged into my trusty lab environment here, and we're going to look at the second example or the second question. So let's open it up. That's question 2, and let's see what it says. So question 2 says PCA, which is 10.99.100, is unable to ping PCB, which is 10.10.10.100 successfully. However, router A, which is 192.168.1.1, is able to ping router B, which is 192.168.1.2 successfully. Troubleshoot and resolve the connectivity issue between PCA and PCB. Alright, cool. So basically one PC can't ping the other PC and vice versa. But the routers that connect to those PCs, which would be their gateways, are able to communicate. Alright, so let us look at this issue using the top-down methodology again. So first question that we're going to ask ourselves here is, what exactly are they trying to accomplish? What's the aim? Basically, the aim seems to be just to get PCA and PCB to be able to communicate with each other. Alright, so what's the issue? Well, the issue is that they can't, right? So looking at this topology, what do we know? What can we establish from this? Well, for starters, we can say that PCA and PCB are on separate networks. The PCA is on 10.9.9.0, it's a /24 network, and PCB is on 10.10.10.0, which is also a /24 network. So they're on two different subnets. Alright, the next thing that we can establish is that they both have their own gateways. PCA has router A and PCB has router B. And router A is at 10.9.9.1 and router B is at 10.10.10.1. Alright, and there's a link between router A and router B on a /30 subnet with two IP addresses, 192.168.1.1 and 192.168.1.2. So these two routers should be able to communicate with each other based on that link that sits between them. Alright, cool. So now that we've established these few things, let's look at our handy dandy what does one need in order to communicate between PCA and PCB checklist. So first thing that we're going to look at is the gateway. First thing, coming top down, is what we need to examine, or what that we need to examine is going to be the gateway. So we know that there are gateways for both of them. Are these gateways reachable by each individual PC? So can PCA reach its gateway and can PCB reach its gateway? All right, let's check. In order to do that, we're going to need to bring up PCA and PCB in remote desktop. Let's log in firstly to PCA. What's this password again? There we go. Nope, that's the wrong thing. All right, let's try this again. All right, looks like I entered it correctly this time. All right, so we're on PCA. Let's just bring up command prompt and let's verify. Let's run an ipconfig on PCA. Let's see what the IP address is. It says 10.10.10.99.100 and the gateway at 10.9.9.1. And let's verify. Yep, PCA is 10.9.9.100. Cool. All right, so let's do a ping test to the gateway and see if that's successful. 9.9.1. Success. So we can reach our gateway from PCA. All right, let's do the same thing with PCB. That's going to be 10.10.10.100. Same password as this is a lab. So let's log in. So we're on PCB. Verify, do the same thing. Verify that this is PCB. Check the IP config information. So 10.10.10.100, and we know that 10.10.10.100, according to the topology diagram, is PCB. So we're on PCB. All right, let's do a ping test from PCB to PCB's gateway. 10.10.10.1. All right, cool. So we are able to reach the gateway for PCB. I probably should have left that way. I'm gonna need it again. All right, so we can reach the gateways from PCA and PCB. So first thing on our checklist was the gateway. We're checking to see if they have a gateway and if it is reachable, and the answer to that is yes. So first item done. Next thing that's going to come up on our checklist is inter-gateway communication. Can both gateways talk to each other? Can they actually communicate with each other? And according to the diagram, there is a link. There's a link on this topology diagram between the two gateways, so they should be able to communicate with each other. So let's verify that that is the case, because remember, it's saying PCA and PCB can't communicate, right? So we're gonna now need to identify where the issue is with that. So first things first, we're gonna log into the gateway for PCA, and that's 10.9.9.1. Let's log into that. And user. All right, so we're logged into PCA's gateway, which is router A. All right, so first thing, let's see the configuration of the interfaces. All right, so we can see that interface configured at 192.168.1.1. Just to verify, yep, should be 1.1, and the other one should be 1.2. So from PCA, or rather from router A, let's see if we can ping router B. Got 2. Aha, success. All right, cool. So we were able to successfully get to router B. Now, the fact that we are able to successfully get to router B means that we should be able to successfully get from router B to router A, barring anything blocking that kind of communication. But let's just verify from router B as well that we can get back to router A. Let's log into router B. User and lab. All right, cool. Verify the interfaces. So this is router B that we're on, right? Let's just verify. 10.10.10.1, router B, yes. We're on the right router. So let's just check the interface configuration, 192.168.1.2, yep. So that IP is configured there, being 192.168.1.1, which is router A. Successful. Great. All right, so the second thing on our checklist is the inter-gateway communication. Can the gateways talk to each other? And the answer to that is yes. We did a ping test from both gateways, from router A to router B and from router B to router A, and both ways it was successful, right? All right, so next thing that we need to find out is, can router A actually ping PCB, right? Can it get to PCB? That's the next thing, as we're going top down. We're checking everything top down to make sure that all the steps are functioning as they should, right? So can router A ping PCB? All right, let's check. Well, we also want to check if router B can ping PCA. So let's check both ways. So let's check if router A can ping PCB, or if router B can ping PCA. Okay, so first let's go back to router A. So we're connected to PCA here. Let's go back to router A. What was PCB's IP again? PCB's IP was 10.10.10.100. All right, so let's try and ping that from router A. Ping 10.10.10.100. Let's see if there's any success. No, it does not seem that way. So 100% loss on this, as in 0% successful. 5 packets sent and none of them received. All right, let's do the same thing on router B. Let's try and ping PCA, which is 10.10.10.9. So let's ping PCA. So that's 10.9.9.100. Let's see if there's any success there. All right, seems like the same thing happening here. No success. Unable to ping from router A to PCB and from router B to PCA. So third thing on our checklist, whether or not the gateway routers can reach the specific PCs, the answer to that is no, right? They are not able to reach the specific PCs. Router A can't reach PCB and router B can't reach PCA. Okay, so the next thing that we're going to check then, if that's the case, before we move into checking anything else, is, are there any access lists or anything like that on router A and router B that's blocking traffic between PCA and PCB? Let's take a look, right? Let's start with router A. Let's go back to PCA. All right, we're back to PCA. Let's checking to see if there are any access lists here that may be blocking traffic, right? So let's do a show IP access list. Number of ways that you can check this here. You could have even done a show run and it would show you the config, right? All right, so there are a couple access lists here. I see a permit for 10.9.9.0, that's its own subnet, and I see a permit for some IPs on another subnet. All right, so not seeing where anything in these access lists are blocking the subnet from, because we're on router A, right? So I'm not seeing anything where in these access lists blocking the subnet from PCA. So let's see if there's an implicit deny in access list. So maybe the implicit deny is blocking if these access lists are applied on any interface. So let's just do a show run and see if the access lists are applied anywhere, any interface. And we're looking, and I'm not seeing where the access list is applied on an interface that is gonna be blocking any traffic from between PCA and PCB. It's applied on an interface, but on a different subnet, on a different network, and Yeah, it shouldn't be. So that's for router A. Let's check the same thing on router B to see if there's anything there that may be blocking it. Back to router B. Let's do the same thing. All right. Same thing, not seeing anything that's blocking network from PCA here. Let's do a show run. And let's see if it's applied on an interface that may be blocking it. It's applied here on Gigabit Ethernet 3 interface, but again, that's in relation to something else on a different subnet, so it isn't actually blocking any communication between or from PCA subnet on router B. Okay, so the fourth thing that we had on our checklist, which was to check if there are any access lists blocking traffic between PCA and PCB on router A and router B, would be no, there's no access list that's blocking any kind of traffic between those two. So this is not an access list issue. Okay, so then the next thing that we're going to want to check is there a route for this subnet on router B? That is there a route for PCB subnet on router A, sorry, and is there a route for PCA subnet on router B? Do these gateways have routes to the requisite subnets that they want to communicate with? So let's check that, because that's going to be the next thing in mind, right? So let's go to router A first, and let's see if there's a route to the 10.10.10 network. And do I show IP route? And I am not seeing a route to the 10.10.10 network on router A. See a number of different routes here, but there's nothing to the 10.10.10 network. Okay. All right. Let's check router B and see if it's the same thing. Router B, show IP route, and yeah, same. Not seeing a route to the 10.9.9.0 subnet here either. Okay, well, that's pretty important, because if these routers don't have a route to those subnets, then they're not gonna know, they're not gonna have a path to get to these subnets, and the opposite subnet, like PCA, is not gonna know where or how to get to PCB because there's no route on its gateway, and PCB is not gonna know how to get to PCA because there's no route on its gateway. So what do we need to do here? We need to add a route. So we're on PCB's gateway, which is router B. Let's first add a route to PCA's, is it PCA? Yeah, PCA subnet. All right, so first we're gonna enter config mode. Let me just verify what the networks are here. All right, so the next hop, we're on router B, which is this router here. So we're gonna have to use this IP 192.168.1 as the next hop from router B to get to PCA's network. So we're gonna add that in, and we're gonna do the reverse, add 192.168.1.2 on router A to get to PCB's network. All right, so let's do that. So we're on router B. So IP route 10.9.9.0. This is a static route, right? So there are no dynamic routing protocols in play here. So we're assigning this route statically. 192.168.1.1. All right, cool. And then, I should have had a continuous ping going. Let me see. Well, I can do it now. Ping 10.9.9.100 and minus T to get a continuous ping going. This is on PCB, so we're doing a continuous ping to PCA. and to see if it comes up after we've done this. So the first thing that we've done is we've added a route on router B to PCA subnet. So we need to actually go now and add a route on router A to PCB subnet, because without that, it's not going to work. It has to be done both ways. So now we're on router A. Let's add a route here. Config mode, IP route, oops, I cannot spell, IP route 10.10.10.0, 10.2.10.0, and boom, whoops, my bad, got to add the next hop, 1, 2, say it, dot 1, dot 2, moving too fast there. All right, so we've now added a route on both gateways. Let's see if we can ping PCB from PCA. So 10.10.10.100. See if this is successful. Yes, we have success. We're pinging PCB successfully. All right. Let's all head over to PCB and see if the ping is working to PCA, because we have a continuous ping going. Yeah. There you go. You can see where it started to work right there. Yeah. So now we have success. PCB and PCA are pinging each other successfully. So the issue was that we needed to add a route on both gateways, on router A and router B, to each of the networks so that they could communicate. Yep.
And that's it. Looks simple, don't it? Yeah, pretty easy, right? Because of course we would check that there are gateways and the servers can communicate with their gateways, or PCA and PCB can communicate with their gateways. And of course we would check to make sure that the gateways are actually able to communicate with each other. And of course we would check to ensure that there are routes on each gateway for each of those networks on the other side so they can communicate, right? Would you believe me if I told you that in my experience, that's not the case at all? Sure, it seems that way because you, the viewer who's sitting at home and watching me, or you're sitting on the toilet, or you're on the bus, or wherever you are, you have me walking you through the whole process. So that makes it a lot easier. So you may be watching and thinking, nah man, this is way too easy, too obvious. Maybe. But these are actual lab exercises that I have used before in interviews that persons were not able to complete. But when you ask them the question outright, they were able to say, this seems like a routing issue, or in regards to the exercise that we did before, this seems like a DNS issue. The problem is, while they may be able to recognize the symptoms and they can probably surmise what the issue could be, their troubleshooting skills are what actually let them down. Now, that's it for today. We have one more exercise left in this series, and that will be coming up in my next video. If you like today's video, please feel free to go ahead and give me a thumbs up. And if you haven't already, please consider subscribing to my channel and hitting that notification bell so that you don't miss any of the updates that we post, right? I'm out for today. I'll catch you guys on the next one.